Okay, this is 1.7 homework help, problem 1. So I put a couple of these on here which should be a little easier and quicker. It says the distance from x to 7 is less than or equal to 1. So when it's asking for the distance from x to a number, that's always the absolute value. Because to find a distance on a number line, you just subtract them and make sure it's positive, basically, which is exactly what this is. So the distance from x to a number is less than or equal to 1 would be c. And then x, any real number that's negative infinity to a positive infinity, so that's b. X is greater than or equal to 7. X is greater than or equal to 7 would be e. The distance from x to 7 is more than 1, be d. And x is less than 7 is b. I'm sorry, x is any real number is a. Don't ask me how I put b there. Okay, next question is about whether or not these could be sides of a triangle. If you remember this from geometry, in order for these to be sides of a triangle, any two sides have to always add to be bigger than the third. So this one would be true. This one's false right here because 1 and 2 had to be 3, which isn't bigger than 4. Right? This one's true. This is true. And this one's true as well. 2 plus 17 is bigger than 18. 18 plus 17 is bigger than 2. And 18 plus 2 is bigger than 17. So every two side always has to be bigger than the third. Then it could be the sides of a triangle. And it's got nothing to do with the Pythagorean theorem because the Pythagorean theorem has to do with right triangles. All right, next question. We want to solve this right here, this inequality. So we're going to multiply both sides by 3. We get 5 minus 2x is less than 21. We subtract 5 from both sides. Negative 2x is less than 16. Divide both sides by negative 2. Now when you divide by negative 2, you have to switch the inequality. It's going to be x is greater than negative 8. Okay, so we're going to put greater than negative 8. Alright, another one. 5x minus 3 over 9 is less than or equal to 1/2. We want to solve this, so we're going to multiply both sides by 9. 9's cancel. We get 5x minus 3 is less than or equal to 9/2. We're going to add 3 to both sides. And we get 5x is less than or equal to 9/2 plus 3. I'm going to do a common denominator, multiply top and bottom by 2. And then add. So I get 15 over 2. Now I'm going to divide by 5. Instead of dividing by 5, I'll multiply by 1/5. That's the same thing. 15 over 10, which x is less than or equal to, 5 goes into this 3 times and into this twice, so 3/2 would be the better way to write it. So we're going to do less than or equal to like that, and then I'm going to do 3 over 2 here, or 1.5. Okay, another one. This one's an easy one, but it wants the answer in integral notation. So we're going to subtract 14 from both sides. We get negative x is greater than or equal to 1. Now divide both sides or multiply both sides by a negative 1, and you got to switch the inequality. X is less than or equal to negative 1. Now I need to write that as an interval. So sometimes it might help to draw a number line here and put, negative 1 right here. We want a closed circle there, and we want all the numbers to the left of it. So that means we take our left endpoint, which is negative infinity. We take our right endpoint, which is negative 1. We're including negative 1. We never include negative infinity. So this answer is what would go here. Okay, another solving the inequality one. Once again, whenever you have fractions and an equal sign or an inequality sign, we can clear fractions. So I'm going to multiply through by 6. And that gives me 6x plus 2 is greater than 2x minus 30. So what I just did is I multiplied everything through by 6 because whenever I see fractions, I like to get rid of them with an equation or an inequality. Now I can subtract 2x from both sides, and that gives me 4x. I can subtract 2 from both sides, and that gives me greater than negative 32. I can divide both sides by 4. I get x is greater than negative 8, and it wants interval notation again. So if you're not sure with interval notation, don't hesitate to draw a number line, and on there put negative 8, and we want all the numbers that are greater than negative 8, so we're going to the right. Okay, so your left endpoint goes on the left, which is negative 8. Your right endpoint, which is infinity, goes on the right. We don't want to include negative 8 or infinity. So left to right, left endpoint, right endpoint of your interval. Okay, now we've got a compound inequality. So we're going to add 2 to both sides here. And we get x is less than or equal to negative 15. And, the word and is important. We're going to solve this one by subtracting 4. And that would give us 3x is greater than 3. Divide both sides by 3, we get x is greater than 1. Okay, so once again, it really helps when you give your final answer as a compound inequality to draw a number line if you're confused at all. So we want x to be greater than 1. So here's 1, here's negative 15, here's 0. So x is less than or equal to, be a closed circle, this way. And greater than 1 would be an open circle this way. So unfortunately, I can't write this as a compound inequality. And that's because I made a mistake. I didn't see that 4x right there. I'm really sorry. So I do need to subtract that 4x still from here. This would, when I do that, this would give me negative 3x. And then when I divide by negative 3, the x cancels, and I end up getting this inequality: x is greater than or equal to 5. So that makes it a little easier. We need x to be bigger than 1 and greater than or equal to 5. So let me redo this number line. We have 1 right here and 5 right here. We need x to be bigger than 1, so that's a open circle. And then we have a closed circle at 5, and we want numbers in between. And they want that as a compound inequality, not an interval notation. So we'll do 1 is less than x is less than or equal to 5. I know you have to enter in your less than or equal to as less than equal to, like that. Okay, the next problem wants us to solve this compound inequality. And it does say it would be faster to use the graph, so they've got a graph for us. They've got the line negative 2 right here. Here's y equals negative 2. Here's y equals 1. And here's y equals negative x, which is the middle part. The question is, when is the green line between the red and the blue? Well, from negative 1 to 2. So from negative 1 to 2, the green line is in between there. Yeah, so I would guess negative 1, and it's both less than or equal to. Now, I don't know if that's faster than solving it. It's really fast to solve it algebraically, too, by multiplying everything through by negative 1. You get 2 is greater than or equal to x is greater than or equal to 1. You always write it, it's a negative 1, sorry. Multiply everything through by negative 1. Then you always flip the inequality. You always put the smaller number on the left and the bigger number on the right. So if you do it algebraically, you'll get the same exact thing as you get from the graph. But it's a good reminder that you can graph these as well. Okay, another one that has fractions and an inequality, so I'd multiply through by 6, the least common denominator, to clear the fractions. If I do that, I get negative 11, minus 3 goes into 6 twice, so you get 2x, plus 6 goes into 6 once, so you get 5x, is less than or equal to 12x. 3 goes into 6 twice, you get negative 2. And now I just need to simplify this. So this would be 3x on the left side. I'll then subtract this 3x over to the right, so it would be 9x on the right. And I'll also add 2 to both sides. So it gives me negative 9 on the left. And I'll divide both sides by 9. And yet x is greater than or equal to negative 1 in my case. I don't know how it wants to enter this in. It doesn't say, so I'm guessing an inequality. So that'd be x is greater than or equal to negative 1, like that. All right, next problem wants us to solve this inequality right here. And it says that the graph of the two linear equations are shown, where the red one is f of x. So this is f of x right here, and the blue one is g of x. Find the interval where the red one is smaller or equal to the blue one. So here's the intersection point right here. So that means from this point forward, for x values, the red one's smaller than the blue one. So that's what we're going to say from -2 to infinity. As an interval, that'd be -2 to infinity. And you can include -2 because that point's included. As an inequality, that would be x is greater than or equal to -2, which I think is what they want here. One more problem then, if you distribute, you get 3x plus 6. If you distribute here, don't forget the negative sign as well. You get -2 plus 2x is greater than, distribute here, you get -3x plus 3. And you can add like terms, so it's 5x plus 4 is greater than -3x plus 3. And you can add 3x to both sides, that give you 8x. You can subtract 4 from both sides, and that give you -1. Divide both sides by 8. You get x is greater than -1/8. So x is greater than -1 divided by 8. Should do that one. Alright, I hope this helps.